Hi kiddos, new day, new test. This one's called partial sums. So let's go back to our harmonic series that you know. If we were to go and list terms like I'm going to do, this is super fun. But remember, it's not the terms we're interested in, it's the sum of those terms to see if that sum converges or diverges. So if I were to ask you for a partial sum, and I'm going to use S for sum, and I put a 1 down here, that means I'm asking you for the sum of the first term, which would just be 1, not exciting. But if I asked you like for S of 3, that would be asking you for the sum of the first 3 terms of the series, etc., etc. These are called partial sums. Are partial sums because they don't go to infinity. We care about infinite sums. The first 3 is not a big deal. Even the first 198,000, not a big deal. We need infinity. So what we're going to look for today, our goal today, is to find these partial sums and then take n of them, the nth partial sum, so the first n terms, and then take a limit as n goes to infinity. Oh, limit again. So that we are getting now an infinite sum. So if this comes out as a number, then we can say converge. And if it comes out as not a number, an infinity, then we say diverge. And the beauty of this test is that this number we converge to is the sum. So this is your second test where your answer, you can actually find the sum of the series. That doesn't happen often. Okay, so let's talk about how to do this. Sometimes, friends, sometimes AP is feeling very generous and they will give you a question where they say to you like, hey, if the partial sum of the series can be written as, I don't know, 2n plus 1 over n minus 7, does the series converge or diverge? And then all you have to do is take a limit of the sum as you go to infinity. And I hope you're getting good at your shortcuts and saying 2, the end therefore converges, and that is the sum. But a lot of times they don't. And here's what we do when they don't. So here's an example. We will only work 1. So these are called partial sums. I'm hoping that you remember that we used the word partial when we were doing something else a while back. Oh, I don't mean to write X's. I'm going to write N's. Do you remember when we did partial fractions? You're all nodding. I'm sure you are. Do you remember we integrated using partial fractions, but the process of partial fractions themselves is just an algebra technique that takes your fraction and splits it up. So this thing factors as n plus 2, n plus 1, and we are going to go find numerators that used to be here before somebody came along, made a common denominator, and added our fractions together. So we'll put them back together with a common denominator. And we will set numerator equal to numerator. And that will help us find A and B. All right, so we can pick whatever we want for n. I'm going to let n equal -1. If I plug in n equals -1, this term with A is goodbye. I get B equals 1. If I let n equal -2, this term with B is goodbye, and then I get negative A equals 1, so A equals -1. So we are rewriting our series this way. Let's see, I'm going to do this. I'm going to do the positive one first, n plus 1, and then minus 1 over n plus 2. Okay, now let's list some terms. These are not your partial sums. This is still just your series. Let's write some terms of our series. We're going to write an nth partial sum. So our first term would be, if I plug in 1, I'm going to get 1/2 minus 1/3. And I'm not actually going to add them because 1, you hate adding fractions, and 2, you're going to miss the pattern. plus if I do plug in a 2, I'm going to get 1/3 minus 1/4 plus 1/4 minus 1/5. I'm going to do one more, and then I'm going to go to the end of this thing because this is finite. This is stopping at n. So if I go towards the end of this, let me come down here. My very, very, very last term is going to be 1 over n plus 1 minus 1 over n plus 2 because that's my nth. Plugged in 1 to get the first, plugged in 2 to get the second, so I plug in n to get the nth. So this is your nth term. What if you back it up 1? What's your n minus 1 term? So if I put an n minus 1 inside, I have 1 over n minus 1 over n plus 1. And I could, I probably should. I'll back it up one more. If I plug in n minus 2, then this is n minus 1 and just n. All right. Oh, minus. We're looking. I'm going to help you try to find some patterns here. All right. I hope you see that we have terms that are going to cancel away. So I have a 1/3, a negative 1/3 and a positive 1/3. I have a negative 1/4 and a positive 1/4 here and here. I didn't write it, but I know this next one's going to have a positive 1/6 inside. So all of these reduce down, all of these inside terms cancel away. All right, let's do it when it's a little bit more abstract and it's just n's. These I can see. These I can see. I can't see this one, but I assume it's here because I'm following a pattern. So it's got to be true everywhere. So our nth partial sum can be written as just, let's see, this is left over. And gone, 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 this is left over. So that entire infinite series, if I just do the first n terms and add them together, gives me this. This is called, this act right here is called telescoping. I hope you see why. I hope you understand why all your insides go away and it just smushes to the first and the last. Okay, so remember your partial series test says we have to take the limit of this partial sum and see what we get. So if I take the limit as we go to infinity, this thing's going to 0, I just get 1/2. And that is the actual sum of that series we started with. So we could have, like if I run through my series test that I have on my salmon sheet, it's not geometric, so that would not have been helpful. If I did the nth term test and just take a limit straight away, I get 0. Still not helpful. If you were going to integrate this, because that's the only other test on your sheet, the technique you would use for integrating is partial fractions, because this denominator factors. So if you find a denominator that factors, partial fractions is your integration technique. So would also probably be your series technique. All right, let's go to the salmon. I wish mine was salmon in here. Maybe I'll just color it one day. All right, this is partial sums. Let's write it first. So if S sub n is your partial sum, what we do is we take a limit of S sub n as n goes to infinity, and we want to get a number. And that number is the sum. If we take a limit as we go to infinity and we get plus or minus infinity, that's a diverge. So some notes I might want to make for partial sums to help myself remember. I'm going to use this word telescoping a lot. The way I develop a partial sums, if they don't give it to me, is by using partial fractions. And maybe I need to make a note to myself that partial fractions happen when the denominator factors. They have to be linear factors. You might need to put in yours as well. But that seems pretty good. So these are the only two. I'm going to mark them with rainbow. This and right here, and this and right here are the only two series convergence tests that you have to actually find a sum. So that's a big deal. Make note. All right, kids, Let me know if you need anything.